We are Team 4. This is our interim presentation, and we'll be looking at redesigning a can opener. Our group members are Nick, Connor, Jack, Evan, Tiwa, and Chris. So can openers are used to open up cans made of different materials such as steel, aluminum, or plastic. They can also include features which allow them to open up bottles. It's essentially a simple lever which allows them to open cans by basically you force the handle closed, which punctures the blade into the can, and you turn the crank, which then guides the blade along the can, which allows you to open it. The reason these exist is because it provides a lot safer and efficient method for opening cans. And there are approximately 390,000 can openers, which are sold annually, and about 10 large US manufacturers of can openers. So the primary consumers for the can opener would be households and food services who are, consuming or serving canned goods. And then the secondary would consist of the households and food services who are using the bottle opener to either consume or serve bottled beverages.
So here's an exploded view along with the list of components of the original can opener design. So it consists of the upper and lower frames, the handle grips, you have the gears, the cutting blade, the rotating wheel, and some other components to help the whole can opener come together. Here is our fast chart for our functional analysis. So the main task function is opening a can, which is realized by the primary basic function of removing the lid, along with the 4 given supporting functions. Branching off of removing the lid, we want to cut the metal of the can along with move along the perimeter of the can. And branching off of moving along the can perimeter, we want the can opener to maintain contact with the can at all times, as well as be able to transfer rotary motion from the user to linear motion. And for sharing convenience, we want to protect the user's hands, as well as enhance the product by including a bottle opener feature.
So for the first assembly sequence, we started with the gear subassembly and put the spacer, cutter, gear pin, and pin clip. Then we went to the handle clip subassembly with the twist pin, the rotating wheel, the gear. Then from there, we added the lower handle, the upper frame, the crank, and then the top handle. For assembly 2, the main difference from assembly 1 is we added an upper frame subassembly with the upper frame and the crank, and then added the handles at the end, but kept the gear and handle clip subassemblies. Comparing the two, we found that most of the criteria had very similar values, with the main differences being the ease of transferring and handling, and then the ease of testing subassemblies, which sequence 2 ranks higher at due to the second assembly and the handles being added at the end. So we decided to go with sequence 2.
So here's our functional component mapping matrix. So here you can see all of the components of the can opener that realize the functions we laid out earlier. So as you can see in this chart, some functions are realized by only one component, while others are realized by multiple components, like maintaining contact with the can. So this gives us a lot of room for improved design to lower these.
This is our bill of materials. We are assuming we would have an annual production rate of approximately 100,000 units. When calculating the part size, we are estimating the stock material being the main factor in calculating the material cost.
For assembly time, we use the time estimation tables for manual handling and insertion. And following the assembly sequence above, we are able to estimate the assembly time to be about 64 seconds. And combining that with the materials cost, we end up with about a $12 per can opener production cost.
We classified these components based on functionality and cost. From using the DfM/A chart, we concluded that a redesign of both frames, both gears, lower and upper pin, and cutting blade, along with the main pivot pin, are all necessary.
In this product family design, we see the functions of the can opener, cup metal, maintain contact, etc. are all similar to customer groups with one exception of open bottles function. As seen in the slide, the lower frame is the module and the remaining components are the platforms. This is an exploited CAD view of a can opener. It shows the function for the primary customer, can opener users, and the secondary customer, the bottle opener users. This is the family assembly sequence. In the original sequence, it shows the two separate assembly sequence that serves both customer groups separately, the can openers and the bottle openers, ending with two final assemblies. In the second sequence, it shows a modified assembly that serves both customer groups with a single final assembly. Thank you for listening.